Welcome to what would have been the Richmond Petersburg Bite of Science, but we moved it to virtual. So I'm just calling it regular virtual Bite of Science. And I would be remiss if I did not start by thanking our sponsors who will certainly pay my salary, but also, help fund our website and keep, try to get you guys some resources. And, when we are in person, they fund the lovely events that we have. And in Virginia, we are sponsored by the Akamai Technologies, Amazon Amgen Foundation, the Arnold and Paige Legend Charitable Foundation, BAE, Claude Moore Charitable Foundation, Commonwealth of Virginia, Gilead Sciences, Illumina Foundation, Jack Kent Cook Foundation, Jacobs Engineering, Janssen Pharmaceuticals, Lockheed Martin, May Family Foundation, Psychmedics Corporation, Spark Therapeutics, TC Energy Foundation, Virginia Department of Higher Education, Vulcan Materials, and WestRock. There we go. And a little bit about the Center for Excellence in Education. So we were founded in 1983 by Joanne DeGennaro and Admiral Rickover, father of the nuclear navy and civilian uses of nuclear power. And our mission is to nurture high school and university scholars to careers of excellence in STEM. And we offer 3 costly programs to students in the United States, which are the Research Science Institute, the USA Bio Olympiad, and the Teacher Enrichment Program. The Research Science Institute, or RSI, as we abbreviate it, is a highly competitive 6-week summer science and engineering program open to rising high school seniors. So kids apply their junior year of high school. And it combines on-campus coursework in scientific theory with off-campus work in science and technology research. And many of the participants go on to do well at competitions like Regeneron, with a lot of them going on to advanced STEM degrees. And I just found out last week that apparently it's about a 50-50 between program alums who go into becoming a doctor versus, a more research field. For registration, applications open in mid-November with the actual application due in early January. And then next up, we have the USA Bio Olympiad, which is the nation's largest education, too many things going on here. It's the nation's largest biology education and testing program. It is open to any high school student. And it's a series of examinations testing knowledge of biology concepts, with top 20 attending national finals in June and the top 4 participating in the International Bio Olympiad, which we actually do really well in every year. And then for anyone who does teach AP Bio or IB biology classes, they actually have a phenomenal set of free resources for teachers and students. And if anyone is interested, registration is actually currently open. And then lastly, we have the Teacher Enrichment Program, is what we're here for this evening. And TEP provides opportunities for middle and high school teachers to connect with STEM professionals, explore some cutting edge research and development, and discover some resources and opportunities that hopefully really provide you with some support for your classroom and students. This year, we are doing some virtual Bites of Sciences. We are starting a new virtual event called College and Career Panels, where we kind of try to help you guys connect the dots between what does post-secondary STEM career and education opportunities look like. We are also doing a monthly series called The Square Root of STEM, where we explore a kind of a common knowledge topic, but that's not, people don't really know a lot about, and really try to share with everyone the fields of STEM that go into what we know about it. Our first one is actually next Tuesday, and it's about detection dogs. So we have a woman who does a lot of research into working dogs, as well as 2 trainers from the TSA talking about their work with detection dogs. Then, as always, if anyone's ever interested in connecting with a STEM professional, just let me know, and I'm happy to do what I can to get you connected. And lastly, we maintain our Lab Bench website, which is hosted on our new website that we debuted, I think, last spring. And to show you what that looks like, it's beautiful. I love it. And this is where resources, videos, the video from today, and all of that gets posted. And so please explore it. It's actually right on the TEP website, so it's super easy to find now and no longer a separate website. So I'm really excited about that. And then lastly, today we have Adi Karisik, and I'm sorry, Adi, if I butchered your last name, who's Global Technology Leader for Operational Technology at Jacobs Engineering. And he'll be talking about some cybersecurity, so I'm actually very excited about that. And then we also have Andrew Doroshenko, and I also hope I pronounced that correctly. Nice, thank you. Who's a mechanical engineer with Lockheed Martin, and I do need to apologize as our other presenter, Dr. Donahue, had to pull out last minute, and he let us know yesterday. So without further ado, Adi, you can take it away.
Thank you. Let me see if I can share my screen and if this is going to work. I do apologize. It's like 14th meeting today and about 7th different platform.
I totally understand. I'm on WebEx, Teams, Zoom, Ring Central, and I've used a couple of others too.
So that's not going to work. We got to do it one more time. There you go. No, it's good. Can you see my slides properly? I do apologize.
There you go.
I have a big monitor, so sometimes it looks super stretched for other people. I kind of kept it on a small frame. Hopefully it works and you can see it well. So as Kim said, I'm Adi Karisik. I serve as a global technology leader for operational technology, cybersecurity for Jacobs. And I'll share a couple of ideas and thoughts and things with you in next 10 to 20 minutes. And I'll start by saying, Andrew, I love the F-35 behind. You know, I've been a pilot for like 25 years. I own multiple aircraft in Virginia. So that's a beautiful picture. Love the plane. So in terms of the background, I have been in this field probably some 10, 15 years. Overall, I have over 20 years of experience. By career, I come from the intelligence community background. And one of the cool things about cybersecurity is that everybody brings a part of their previous life into that career, and you can find an interesting way how you can integrate your life experiences into understanding and the threat environment that we're dealing with. Now, the cybersecurity that I play with is a little bit different. You know, I don't protect your data. I'm more about protecting that plane behind Andrew in terms of the systems and critical infrastructure pieces and so forth. But I'll try to present it in a way that to give you guys a little bit of a challenge in terms of mentally to kind of get a new spin on things and where the things are going. Because if you look statistically, OT cybersecurity is currently #1 growing the digital discipline in the world. Typically, we start every Jacobs presentation with something we call moment of caring, which is aimed to give us a little bit of a reflection on ourselves and kind of center us about the topic we're about to discuss. So I chose a topic for this presentation of mental complacency. And let me explain what that mental complacency is. Basically, it's when we start identifying past as standards of the future, when we are when our relevancy in a professional sense is in a past tense versus in a organized towards the future, and that affects the organizational behavior of the whole organization. Let me give you an example and how that works in real life. I was on one of our major global clients site several months ago, and they were asking me to take a look at the particular process. The client is classified, but the process is very simple. And if they're doing this the right way or the wrong way, and what my opinion would be of how they're doing this thing. And I, after looking at the process, I realized that there are 2 steps in that process that are totally useless and redundant. There is no value added. So I figured out I would be a friend and good contributor that would take type of a thing such as complicated process, simplify it, and give them some of those work cycles back. So when I offered it, the client said, well, I understand what you're trying to say, but George personally designed this process. And unless he thinks it's different, that we're going to do it this way. I'm like, okay, can I talk to George? Maybe he can explain to me why we have these steps. I said, no, you can't. He retired in 1987. But the problem that we have is that a lot of people are stuck in this mode of this is the way we're always doing things, and they're not willing to change. In contemporary time, we call this inability to think outside of the box. So I know we have several people on the call, and I'm going to ask you a very simple open question. Do you think we as a group here can think outside of the box? Do you think we have that capability? Yes, no, maybe?
Absolutely.
Absolutely.
I'd say probably, yeah.
Yeah, well, let's give it a try. So I'll give you a little test. And the test is quite simple. I'm going to ask you, how fast can a person ride a bicycle? And the answer I'm looking for is miles per hour. And here are the conditions. Has to be on a flat surface, has to be without any engines and motors accelerating to that maximum speed, has to be human propelled, no pushing or pulling at top speed. And I'm not looking for that person to sustain the speed for 20 minutes. It's that top speed that they're able to hit with their muscle movement. So what kind of bicycle? I don't know, whatever best money can buy. What kind of person? Lance Armstrong, fully juiced, right? It does not really make a difference. So with knowing all of that, does anybody have an idea? Can you throw out a number in miles per hour? What do you think this would be? Do you think they can go 30 miles an hour? 40? There we go. Okay. Anybody thinks different? Anybody want to try with 50 or 60?
You said flat, right?
Flat. And by the way, it has to be verifiable. Whatever I tell you the answer is, I got to show.
Well, there's no mention of whether it's in a vacuum or not. So
Okay.
maybe some high fraction of the speed of light.
No, in miles per hour. And so it has to, I'll tell you, actually, it was done in open field.
We have a guess of 60 miles per hour.
60 miles per hour. Okay. So let's say, can I say that in everybody in the room, we're looking at the range of as low as 20 or 30 and as high as 60 miles per hour. Would that be everybody's answer in that block? I think so. So, and the correct answer, I'll give you one more fact. The person who holds the record in the Guinness Book of Records is a lady by the name of Denise Miller Korenik. When she set this record, she was a mother of 3. She was 45 years old in 2018. The previous record holder was Freddie Rumpelberg, the Dutchman who did it in 1995. He failed first time and broke 24 bones during the fall. So the correct answer is 186 miles an hour. Let me show you what that looks like.
Dennis Mueller Korenek.
I'm sorry, 183.9. That was 2 miles off. So she has a pacing vehicle that starts her up to about 60 miles an hour. Then she detaches and continues pedaling and accelerating. I'll fast forward it a little bit so you can see when she detaches. Somewhere right here.
157, so 163 in the first mile. Looks like she's closing in on that. At 170 they're looking for.
She is drafting, so Andrew, you had a pretty good guess on that. Because even detached, she's using that vehicle to shield her from wind resistance. Anyhow, the reason I brought this as an example is, well, we all think it's easy to think outside of the box. We always revert to these known commodities and standards, you know, of 40, 50, maybe 60 miles an hour. Anything else bigger than that on a bike is a superhero move. The other thing that we're witnesses of today are the current digital trends. So the digital requirements and digital standards and digital problems of today's world are not confined to one particular geography. Before, you could have solved the problem on a regional level. Now it's all global. And then the only way people can understand the true value that technology brings in life is, I use the analogy of a Smith's Island cake out of Maryland. You know, it's a really good cake, multi-layered, very, very good proportions between the sponge and the filling and all of that type of stuff. But in essence, the technologies, the science, the ability to leverage what's in future against the existing projects, programs, and clients is in a layering this variety of technologies, one on top of the other, just like the layers of the cake. So in the beginning, I said I do the OT cybersecurity, and I'm going to try to explain what that is and how do we do that. So IT, or information technology, applies to any organization. This is your PCs and your emails and your printers and the equipment that's connected in your local IT network within the place of work or at your home. OT does not cover data. We don't care about your email. We don't care. We care about protection of physical things. So there is no secrecy per se in what OT protects. For example, in the example of the plane behind Andrew, there are certain parts of that plane that are considered classified. However, the fact that it's using avionics is not classified, and protecting that avionics system will be the OT, not an IT function. Jacobs is one of the few companies around the world that's able to combine both services. And where do we see that typically? You know, for example, the Gartner defines the OT as protecting people, assets, and information included in control of physical devices. So it's all about protecting physical things. At some point, OT and IT connect and merge, and we'll talk about that. But most of the stuff that I do will be on your industrial control side, on your utility side. I'm in Virginia, so Virginia Department of Transportation, for example, is one of the most technologically advanced DOTs in the country. Has more fiber than pretty much anybody else on the East Coast combined. And protecting these type of assets becomes a very big challenge, and it can be of personal interest to individual as well as the national interest for the country. What we leverage is, when you look at the organizations, is something called the Purdue model, named out of the Purdue University. And that shows you how enterprise functions, where all the OT stuff that is protecting physical things is below the yellow area, so the blue and purple. And everything that's IT is gray and blue on the top. So that is kind of how the organizations are divided. For example, in education, we do a lot of smart campuses around the world. And what we would cover in OT is a typical, most common thing that gets educational institution hacked is actually controls for the HVAC systems. Once you get into the HVAC, you can go anywhere else around that network, right? So the HVAC controls are probably the biggest exposure of a lot of educational organizations to hacking. So if we look for generally how people get hurt through bad implementation of cybersecurity, there are three main areas of concern, and this is the top three out of the issues that companies and organizations report. External hacking, 50% of all companies are vulnerable to that. Second one is malware. And the third one is social engineering. Social engineering was under 10% 3 years ago. So this is the biggest spike in terms of the risk. And the social engineering starts and stops with us generally being nice people. Let me give you an example.
We're talking about cybersecurity today and how safe people's passwords are. What is one of your online passwords currently?
It is my dog's name and the year I graduated from high school.
Oh, what kind of dog do you have?
I have a Chihuahua Papillon,
And what's its name?
Jameson.
Jameson. And where'd you go to school?
I went to school back in Greensburg, Pennsylvania.
What school?
Hempfield Area Senior High School
Oh, when did you graduate?
in 2009.
Oh, great.
It's like my cat's name and then just like a random number.
Okay. Has you had this cat for a while?
Yeah, she's my childhood pet.
Aw. And what's her name?
Her name is Jolie.
Jolie. So like a password of yours would be Jolie and then a number.
Yeah.
Like number 1.
Like my birthday,
Oh, when is your birthday?
June 12th,
Oh, nice. And what year were you born?
95.
Oh, great. So Jolie, 6/12,
Nine.
95.
Yes.
Got it.
So you mean to give my password right now? No, I cannot do that.
But we all want to know what it is so we can tell you if it's strong or not.
Oh my goodness. Let me think. Okay, one is Tel Aviv. Yeah. 468, and then Israel. It's only 3, but it's for me it's strong enough.
Ireland, 1, 2, 3, 4. Gemma, 1, 2, 3. Spelled Gemma.
Well, most of them are Italian.
Oh, beautiful.
Yeah. So
what? Like what's a good Italian password?
my grandma's name,
What's your grandma's name?
Maria.
Maria. So Maria is your password?
Oh yeah, now you know my password.
We're talking about
Just to kind of give
cybersecurity.
you an idea how this all works out, the social engineering is because typically we don't expect people to mine for information to elicit password information from us on the street. We as company, as Jacobs, have a pretty unique approach in securing the facilities we take care of. First of all, we're not just the consultants, we're also the operators of hundreds of water utilities around the world. So we have the ability to see the angle of operations and angle of consultant at the same time. One of the cool and new things in the cybersecurity arena is utilization of these new IoT or IIoT cybersecurity devices that are all over the place. So they present additional risk, and I'll explain why. First of all, if you look in a construction field, nobody's building, like in a field of education, nobody's building a dumb campus. It's all smart campuses now, and smart buildings, and smart parking places, and smart elevators, and smart thermostats, and everything else. So by being smart, it implies it's either connected to internet or it's digital in its form, which creates a bigger footprint and attacking platform that a bad guy can attach to. Our bad guys are more motivated because with everything that's been going on, I mean, we had Colonial that they made money on. We had the Oldsmar, Florida water plant that they made money on. Had another one in California a couple of months ago that they made money on. And we're talking about payments of millions of dollars. So they like that, and they like to make money of organizations. In Georgia, a whole county was blocked because they got under a ransomware attack. So these guys are getting more money. They're more motivated to hurt general populace, and they're becoming more destructive. And on the security side, the enterprise security operations centers have no visibility. They see your email and your payroll information, but they really are not tracking your HVAC controls, your elevators, escalators, security cameras, and so forth. So this turns into a business risk, because if you're under attack, even if you don't end up paying a big amount of money, you're still potentially dealing with a production downtime, with the loss of sensitive or intellectual property that they can steal, and variety of safety and environmental incidents. The other thing, I call it laziness, because most of these IoT devices were designed not necessarily to make us more secure, but to make our life more convenient. So instead of you punching the code at the door, now we have a card that the device reads and we'll get let into the building. The problem is these devices that we bought, nobody knows who makes them, what kind of software is in there, what they're designed to do. There is no vetting. All we know is they're cheap, and we're buying them by a pound because they're cheap and they come from China. They're not designed to increase your security. They're designed to make your life easier. And because they're cheap, they're not really secure. They use a lot of open source cheap components that are very easy to hack or get access to. In 2020, last year in July, the United States government, primarily the CISA or NSA, issued an advisory saying that, you know what, all these cyber attacks on infrastructure, on key facilities, on government entities, schools, it's going to continue and it's going to get worse in future. So who does this? Everybody, from a variety of nation states who are sponsoring this type of activities to other threats, which is the local, 14-year-old in mom's basement trying to see if he or she is cool enough to get into a school computer, to insider threats, which are disgruntled employees, and those are now turning into more and more damaging scenarios. And I'll demonstrate. First of all, insider threats on a water system in one of the southern states. In 2017, they discovered that employee in the IT department has put in illegal operation on which they were running all kind of financial scams, and everything was coming back and clearing the money. Money was laundered through a official county site. So just to kind of give you an idea how people get creative. The other thing, probably the most known one, is a place called Maroochydore in Australia. And the story about Maroochydore was when it broke the news, and it came in with a statement, hey, hacker was in jail because he did this. Here's the reality. Here is what really happened in Maroochydore. So the story about Maroochydore is very complex. The guy did what he did. He released almost 1 million gallons of untreated sewage intentionally into their parks, river, and hotel grounds, creating ecological disaster. But the problem that there was, this guy was a temporary employee. By Australian labor law, as long as they have an active employee in that billet, they cannot hire somebody else for the same job. So he was like a temp to hire type of, or substitute teacher type of thing. And the person who he was replacing temporarily was on a medical leave, somebody with very serious disease who was in hospital for 11 years. Eventually, that person passed away, and the water treatment plant, or in this case, wastewater treatment plant, opened the job requisition looking to backfill the employee who is now deceased. The gentleman in question applied for a job because he was doing it for 11 years, but he did not get selected for the job. So they escorted him off-site, but forget to take his credentials, access to network, access to controls the wastewater system. And they say, oh, he hacked into it. No, he did not hack. It's an insider threat. He used a valid password and valid credentials to gain access to the system to do what he did. Another good example in this field is, I was sharing this with a particular customer in the state of Georgia. And they told me, you know what, this is scary and we have zero policies on our passwords. What do you recommend we do? And I said, well, what I think you need to do 2 things is buy yourself a multi-factor authentication kit. And before you do that, set up 2 rules in your password allocation. One is password complexity. And the second one is password expiration. So your password will not be good for 15 years. It'll be good for, 6 months and you have to change it. So they put these policies in place and they wanted to impress us how safe conscious they are. They put out the requirements for all employees. Password will be good only for 7 days. It has to be minimum 42 characters, minimum 19 special characters. Look, I don't consider myself to be a dumb person, but there is no way I'm going to memorize another 42 character password every single week. So as a result, all of their employees printed their passwords and they're posting them all over their cubicles and offices. So all you got to do is walk around with a camera and figure out what the password of the day is. Of course, we talked about the ransomware, and I'll give you the example. Texas Department of Transportation paid $64 million last year in ransomware fees. The first US infrastructure attack was in 2017. They asked for $5,000. So we went from people attacking for $5,000 to people attacking for tens of millions of dollars. So finally, in today's world, no environment is safe from these cyber attacks. And the worst thing we can do is underestimate the ability of people to do things. One has to be aware of what's available, ask for help. There are plenty of free resources. I'll share a couple of slides that you're more than welcome to share with your students with free resources, how to get smart on this. And then what do we do in cybersecurity? The biggest concept, you know, and I'm using this just to demystify. People think cybersecurity is something super new, techy, and complex. It's actually very simple. The biggest concept of cybersecurity is something called defense in depth. And what that means is, I'll go back to the same slide, sorry. What defense in depth means is what that graph presents. You have a layer of defense on each layer of what you're trying to protect, on device level, application, computer, network, and so forth. When people look at that, they say, oh yeah, this is high-tech stuff, but it's really not. You know where this comes from? It comes from this, defending the castle and multi-layer defense. So they didn't have device and a computer and application. They had the moat, and once you defeat the moat, you have to get to the archer towers. Once you defeat that, you have to breach the wall. Once you get in there, there is a courtyard surrounded by archers. Once you defeat that, you have the castle wall that you have to break into. So it's just adding layer after layer of defense and using common sense. That is all there is. The big mystery, and I think you know, the two words that don't really go well in a critical infrastructure word is both C words. One is COVID, that nobody mentions, and the other one is cloud computing and putting data on the cloud. Everybody's afraid of that. So the fact is, we're going to be destined to move towards the cloud integration eventually. It's just our own discomfort that's keeping us separated at this point. The other thing is system integrators, your contractors, when they come to your site, do they follow the cybersecurity best practice, right? Are they computers that they're connecting in your offices to check your systems? Are they virus-free, malware-free? Who's checking on that? And this is all very logical and simple stuff. Finally, you got to practice your files that we call the crown jewels of your organization. They need to be protected. And if you think about the best concepts, everything from physical security to network segregation to multi-factor authentication, backups and disaster recovery, most ransomware attacks are irrelevant if you have a good backup. Now, I want to stop on this side for a second, and I'm almost done. This network segregation via firewall is one of the newer concepts in technology, which shows how we can have devices communicate in this demilitarized zone, so there is no virtual connection, and it reduces the possibility of spreading of attack from one environment to the other on the cybersecurity side. So again, same as a castle, this one came from the ancient city of Babylon, right? So history teaches us that the city of Babylon had two sets of walls, the inner and outer walls. They didn't worry about the cyber threats, but what they were worried about were diseases. So if you were a merchant from out of town that came to do business with the city of Babylon, you would be allowed to approach the inner wall, but not go through. So all trade was happening outside the city borders between the two walls, which is the same as the DMZ concept I was telling you about. Last week, I was a guest speaker on some UK cybersecurity conference, and one of their government representatives asked me to make a comment if removing internet from everything that's important would make us more cyber secure. And I said, it's not, the problem with that concept, it's like trying to protect your house against burglary by removing all doors and windows. Yep, they can't break in, but you can't get in or out. So it's not about protecting the access, it's about controlling the access that is important. And that the art of remote access management is a very complicated feature And in our case, Department of Homeland Security has a whole manual of who can get what type of access from remote. And finally, US is one of the blessed countries that we have a lot of good regulations that people can read and understand. They're not complex to understand. You know, it's all common sense stuff. Put in the policies, plans, and procedures, and you're getting the basis of cybersecurity. For example, typical application, or in industrial case, HMI, cybersecurity, is the same concept of that layer defense, right? Defense in depth. So you have, does the person have access to the computer? Does he have the right credentials? If he has the right credentials, does he have the right permissions to manipulate the data? Oh, does he have the credentials to enter the certain application? Does he have the right user permissions? And then he can do what he or she has intended to do with data manipulation. Finally, backup is important. Backup your files as often as you can. The industry standard is 7 different versions of backup at different locations. You don't have to do that for a lot of private stuff, but you know, what I'm talking about here mostly applies for the big complex systems, but it also applies to your home. Well, you don't necessarily have the escalator controls and elevator controls in home. You know, personal story, my wife just replaced our fridge, and apparently our new fridge has internet now. And the screen, and the connects to my phone, so I catch myself talking on refrigerator. But the you know, we're very tech savvy in our household. We have firewalls all over the place, but I don't have a specialized antivirus for my refrigerator. I don't have a firewall designated for my Keurig to make coffee in the morning. And all of those devices now connect to internet, and they're trusted on your network. So if I'm to hack into your home, those would be the accesses that I would look for in order to gain access to the rest of your home network. Finally, the 5 big pillars, and this is, I think, my last slide, the 5 big pillars of cyber resiliency. We can't protect what we don't know you have. So the first step in understanding how to set up a defense is figure out what your asset list is. What do we have to protect? After we figure out your asset inventory, next thing is to run a risk and vulnerability management, or basically run the analysis to figure out which devices are important and what devices we have never allowed somebody else to control. Based on that, we create a variety of operational efficiency standards, and then unify your IT and OT security monitoring, because the only way you're going to know, nobody can prevent you from being attacked, but knowing that you're being attacked helps a lot. And finally, incident response, threat intelligence, run your algorithms, run statistics, and figure out, you know, who is attacking you, why, what are the common avenues of attack, and everything else. And different organizations deal with this differently. You know, I have a client in California who told me they have a way how to get the best cyber defense. And they went, and it's a very sensitive piece of infrastructure. They went with a camera, recorded everything, and posted it on YouTube, and asked public to give them ideas how to protect them. You heard a lot of times that people say that safety is important. Everybody shares safety at work. I believe cybersecurity is organizational-wide responsibility, and everybody should be in the risk, in that loop. Finally, these are some of the resources. The last one, the ISA 99, costs money. Everything else here is free. So Google them. You can find a lot of useful information. The young brains are usually susceptible when they start reading this type of stuff and playing with it. They come up with most amazing things that we old guys probably don't have mental capabilities to figure out. And that's it. Thank you so much. And I'll open up for any questions.
Thank you so much for presenting. If we were in person, we would all clap for you, because it was, what a wonderful presentation. And I gotta say, I've seen a number of cybersecurity presentations, and sometimes I watch them and I'm like, I'm not really seeing what's going on, but this was really, really wonderful in terms of really explaining kind of the entire ecosystem. So thank you so much for that. And we do have a couple of questions. Because I know you had mentioned, so you had mentioned in the beginning that I guess you still are a pilot.
Yes.
And it sounds to me like you've done a variety of things. And I guess, especially with cybersecurity, it's a lot of like, what people call like the systems thinking.
Yep.
And I guess, could you tell us a little bit about kind of what, what have been the most valuable like skills that you've kind of transferred between, things that you enjoy and, and careers?
Absolutely. I'm sort of a weird guy when it comes to careers, right? So I was supposed to be a military officer, ended up in the intelligence realm for the first part of my career. I do unusual things. I'm a pilot. I own a couple of flight schools in Virginia. We own propeller aircraft, jet aircraft, all kind of stuff. I sit on Rock and Roll Hall of Fame board. I work with musicians all over the country. I'm a still active practicing magician. I'm banned from all the casinos in Vegas. So I don't gamble, so it really doesn't hurt me. But I used to work for them trying to find the cheaters. And and my most probably useful skill from my previous life that I still teach at Naval Postgraduate School and a couple of other non-public government schools. I'm a profiler by trade, right? So the ability to anticipate somebody's thinking pattern and know which way they're going to go, you can apply to any profession that you have. And that was probably the biggest gift that I got. That gift comes with a price. You can't turn it off, right? So, I used to get paid a lot of money to tell when somebody is lying to us or not being completely honest. But, when you go out and sit with your friends and you say, well, did he just lie to me? that comes as a price of not being able to shut that down. I think that probably would be the most useful, that and ability to quickly analyze a large amount of information and decide quickly what's the right course of action. Those would be the two critical skills that I think.
Awesome. And we have some students with us today. They're out they're still in class in California. And they want to know, I guess, what would you tell high school students to do and if they were trying to enter a career field, your career field?
Which, the cybersecurity one?
Yeah.
Okay. The cybersecurity one. First of all, you got to keep your mind open, and don't be afraid. It's going to take some practical and technical training and education. There are plenty of internships available. You just have to decide. There are two paths in the cybersecurity. You can go the information and data protection, or you can go this type of stuff with the operational technology and physical facilities and things to protect. You have to figure out what suits you better. In IT world, there are a lot of people who do that job, but the environment is probably a little bit nicer. In our world, you might have to go inside a submarine, or you will go inside the airplane to figure out what's going on with the cybersecurity, or you'll go inside the water treatment plant or a wastewater treatment plant where it doesn't smell super nice, right? So you're exposed to a variety of things, and you will sometimes wear a hard hat and steel toe boots, even though you're a cybersecurity expert. And please feel free to contact me, and we offer internships. We will work with everybody who wants to get more knowledgeable on this, because the passion is to create next generation of people who can do what we do.
No, and thank you. I really like your comment about, cybersecurity, but, being out in the field, because I think, my experience in the education side, when we talk about cybersecurity, it's a lot of just, it, always seems to me that it's just like, sitting behind a computer doing computer stuff all the time. But I think, hearing that, it can be more or different from that, I think is really, really exciting. And then actually, I think another question about if Jacobs offers internship and scholarship opportunities for high school students.
Yes, I don't know I don't know in which Jacobs is a very, very big company, right? So
you are a very large corporation.
Yes, we're in 140 countries. We are depends where and what type of internships and stuff. I take in my group probably 2 to 3 interns every single season. And the idea is not to just to expose them to some of the things that we do, and some of those things are cool. Like, I had 2 interns last year when we were doing the cybersecurity for the Super Bowl, right? 2020, it was Miami. We had 2 interns join us there. We didn't get to see the game, but they got to see what happens in the background to make sure that event goes fine, right? For protecting, in this case, it were water supply systems, because if you're going to introduce something bad to the mass amount of people, water is a good medium for that.
Awesome, thank you. And I will certainly ask my contacts at Jacobs about that as well, who are in more of the corporate responsibility department. And then I guess, so one more quick question. I know some, like, when, like there's those little devices that, like, there's a code that switches every however many minutes.
Yep.
I guess what are, sorry, you're talking about all like passwords and all of that. And I guess it made me think of it. So what's your thought on, like, I guess, how secure are those?
So, some are more secure than the others, but in essence, you have to understand that those devices by themselves are not a threat. So it's a secondary method of authenticating who you are. It's not the primary is still your password or your fingerprint or your retina scan or whatever. But as a secondary one, you don't need as much security on it. The newer generations of those devices are not being carried around in a little keychain anymore. They're typically either part of an app, or it will send you a particular text message with a code just to verify that you are who you are. The idea is just to have a multiple verification points that will prove that the user is who they claim they are.
Awesome. Thank you so much. And with that, we can, Andrew, you can take it away.
Awesome. Let me get my slides up here. Bear with me for a second. Screen 1.
Do you also have Suite multiple screens?
I want to use the one right in front of me. Yeah, I have 3 right now.
I'm always
I don't
so
usually
jealous.
use the laptop. Yeah, I usually use 2, but I'm using the laptop because it has the camera. Is it this one? What do we see? What do we see? Do you see anything?
Yeah.
Oh, that's the right. Okay. See, I don't want that one. So I do want one. Okay.
Yeah, don't worry. We edit these parts out.
All right. Do you see my blue screen now?
I see an email.
Email again? Darn. All right, that's fine. I'm just going to do the middle one. All right, you should definitely see it now. You see it now?
I do.
Great. Okay, so I'm Andrew Doroshenko from Lockheed Martin here in Bothell, Washington. We have got a couple other folks on the line from my site today, Evan and Ratnanjali. If you have anything to add, just feel free to throw it out there. I don't really have a ton of slides to go over here. Just kind of want to do a brief overview of what we do at Lockheed, as well as what I do specifically, and then some suggestions I have for general STEM activities. This is run by the STEM Council. We have a little STEM Council here at our site that does outreach to different schools and to I guess TAF as well for different events virtually, and so this is our part of that. So a little bit about me. I grew up in New Jersey. I always thought I wanted to be a airplane designer since I was a kid, my dad would make me like paper airplanes and help me with really intricate paper airplane designs, and then I would modify them to do different things, and I just kind of set on that engineering mindset. Started out with like, you know, Legos and building and design type of activities they're stimulating, right? So I did science fairs, home projects, extracurriculars like a robotics club at my high school, as well as in college. I did extracurriculars that were engineering based, really, to give me experience and improve my chances at college and job. I also do RC airplane building. I haven't done that in a little while, but I was big into that coming out of college, since I was a team lead for my aero design club there. So on the bottom right here, you can see a picture of my giant scale RC plane taking up most of the garage, made of balsa and plywood here. Very relaxing experience. And you can apply engineering as well, while also doing sort of more like trade arts and crafts. So I enjoyed that. Yep, top right is also being a mechanical engineer helps with various other activities like fixing your vehicle. So I have an old Bronco here I'm working on getting fixed up. So what we do here, I'll just go in a little bit more. What I do specifically, I have been involved in a lot of different engineering disciplines at my site. We are essentially a prototyping shop, which is kind of what you see here in this Big Bang Theory screenshot, where in a prototyping lab, it's very fast paced, you're innovating on the fly, creating ideas to solve problems, trying it out, and then trying new things. So I've kind of gotten the opportunity to get my hands in a lot of different aspects of what we do, including heat transfer analysis, computational fluid dynamics, structural mechanics. So that's actually, you know, does something break when you apply loads? Mechanical design. So I use Creo and do CAD work and design mechanical parts, make drawings for them. And an important part of that is geometric dimensioning and tolerancing. So will the parts actually fit together? Something that's not really taught in school or even university, from my experience. Part inspection, so actually getting hands-on. I actually get into the lab, I inspect parts as they come in, assemble components, see if they work, and then if they don't, go order more parts and try it again. So I'm kind of just like I haven't watched Big Bang Theory in a while, but the one actual mechanical engineer from that show that's kind of tinkering in the lab. That's kind of what I do. And an important aspect that often gets missed from what engineers do is that we have to be extremely social. We have to collaborate a lot and communicate a lot with our team, with the customer, with program managers that don't have as much technical background. So it's really important that we actually collaborate a lot in a team environment. I really think that any engineering degree or, you know, science learning is it's not really complete without doing some team activities, without being involved in a team. You can't just be book smart. You also have to have some, you know, social skills, I guess. So that's definitely critical. Let's see. Yes. So some examples down here are kind of interesting. On the bottom left is like a typical hand calculation for convection heat transfer. So cooling a computer chip by a heat sink, you know, metal heat sink with lots of fins on it. Actually sizing that, you can do that with some basic hand calculations. And then on the bottom right here is a picture of a CFD simulation. So air, I guess, going into a radiator, not exactly sure, but you can simulate the way liquids flow through components, and how heat's transferred and what happens with pressure drop and all those things. That's something that we have to do as well as part of the whole cooling design process. And in the middle is just a screenshot of some Creo mechanisms. So do a lot of that. So overview, a little bit more about my company. Not too much about this, but Lockheed Martin, if you've been to an aerospace museum, you've heard of Lockheed Martin. We have a lot of planes in there, from F-22 to, SR-71, Blackbird, we have 4 different divisions. We're a huge company with aeronautics division, missiles and fire control, rotary and mission systems, and space. So you can get a pretty good idea for what each of these divisions does just by their name. I'm part of the rotary and mission systems. So what we do is more the mission systems side. So getting into, so getting more into that. Next, at my site specifically, we work on directed energy, which is new technology. It's been around for a little while, but not in the same form. In the past, we've had airborne weapon system. I think it was a 747 with a giant chemical laser on it. But there's a lot of problems with that. And I think that the project eventually got canned. But now, with the dawn of electric lasers, there's a lot more possibilities. And so this technology has been growing and scaling up, and I like to consider it sort of golden age of directed energy, because there's so much development at such a rapid pace and a lot of competition. So that's exciting. So on the left here, you can see Army, and then bottom right is Navy, and then upper right, Air Force. So we've got all branches of the military interested in directed energy, putting a high power laser on a platform and using it to defend against incoming missiles or shoot down ICBMs, stuff like that. That's the goal here. So really, it's defense here. And you can kind of see a little drone or something here being shot by this animation right there. But yeah, so great pictures. A little bit more general here. Getting into what I like to more or less convey to students during these STEM activities is the process for design. Well, first there's getting them interested in doing these projects, and then actually implementing it would follow this process. So it's pretty generic. I mean, you've probably seen it before. Ask what is the problem, and then start brainstorming solutions. Plan out, spotlight video. Plan out how to solve the problem. So planning, it looks like a small step right here, but planning is everything. So that involves creating drawings, creating designs, having design reviews, all of that. Creating the actual project or product. So that's actually building it. If you did your planning right, then your creation step will be a lot easier. So emphasis on the planning. And then testing and improving, that's the fun part. So whenever we get into that stage of the STEM activity, that's where everybody's smiling, having the most fun, and hopefully being motivated. And then after that is sharing, and essentially telling people about your successes, and then maybe being able to do something else or interesting. And also debriefing and learning from mistakes and whatever happened along the way. So on the right here, I added a few sub-steps on each of these generic steps of the design and engineering process. So in industry, during the ask and imagine phase, you would have a request for proposal. You have a customer with a specific need comes to you, hey, we need to, put a giant laser on a ship or whatever, So, okay, well, let's see can we do that? And then we would consider whether we want to make that, if that'll be profitable for us, and then maybe move forward with creating a proposal and being part of the bid. So So there in the classroom, it might be, you know, you give a student like a couple of choices, or, you know, create a solution to this problem, and then you'd brainstorm different creative out of the box ways of solving that problem. And then if you get the bid, then get the contract, then you start the planning phase. So this is really where there's all the work happens during this planning phase. That is all the engineering work, and where the entire team is engaged. So you start with requirements. What does your customer really want? And there's a lot of interesting, I guess, takes on requirements and how requirements can be flowed down wrong. A lot can go wrong in this step, where if the customer doesn't specify exactly what they want, you could give them something that's not actually as useful for them. Or with scope creep, they change what they want, and then eventually it changes into a completely different product that isn't really what they needed in the first place. So it's really important to communicate with the customer what exactly do they want in terms of requirements, and what kind of a product do they want, and then trying to stick with it, so that you don't have sort of suboptimal product for what you originally started out with. So let's see, and then trade studies. So trade studies happen throughout the design process, continually looking at different ways of solving problems. You can create completely different conceptual designs. You can have different subcomponents, or even just different adhesives for certain applications within your product that you have to do trade studies on. So there's a lot of sort of taking it slow, making sure you make the right choices, and have educated decisions for each of your design decisions. So a big step that I only really learned once I was in industry, actually practicing for a while, is the different design reviews, reviewing with your team along the way. The main ones are conceptual, preliminary, and critical design. So conceptual is you have a general concept, you're very early in the process, and you can make big changes easily in the conceptual design phase. You really want to make sure that you have a overall package size for your product that you think will work and you can work within. Then you work into the preliminary phase, where you start getting more detailed, and then at the critical design, once you pass the critical design, then you actually can start buying things, because you did the full detail design and you are very confident that your design will work. So those are essentially just steps, or gates to actually start ordering things. Yeah, and all within the planning stage is design, like the CAD stuff I was talking about, analysis, convincing yourself and your customer that your design will actually work. A lot of collaboration going on, a lot of planning. That's kind of redundant, but planning involves like looking at the schedule, making sure that when you order things come in on time, and work with your schedule. Working with procurement and your entire team, making sure you have resources or people available to help you along the way. So yeah, that is all for the design phase. Hopefully this is useful to everyone. Sort of a just general overview of this design process. I'll keep going through this. This is the bulk of my content, I think. So let's see, prototyping, risk reduction testing, process creation is all part of the create process. So you need to convince yourself that things will work and not think that you can just create one and done. Having a prototype helps a lot so that you can find your issues early. And then testing and improving the product. So something that you don't really think about until you get into the world of large complex products is how many requirements there often are. So you'll have a huge list of different requirements to to test against, and you'll run many tests and make sure everything works exactly as you want. So you have to be kind of methodical about that. And then finally, there's delivery to the customer, and even support and maintenance into the future. So any questions on this, or anything specifically on the design process, how this can be implemented? I don't know if there is anybody looking at projects, engineering type projects for their students, and thinking about, okay, how do we make this fit within a school year? Or I don't really know what your particular applications are. So I'm just kind of, yeah.
No questions, but I really liked your industry examples of the pieces.
Thanks.
They're actually very helpful.
Yeah, so I'm part of I just graduated from this leadership development program here at Lockheed, where we actually sort of go through all of these particular items in detail and practice with them, and with mock customers. And so we get a really good understanding of each step of this process. So it's kind of just an essential skill as you go into industry to understand each one of these. So one of my last slides here is just some general inspiration. So what often inspired me, I guess in high school, college, and before, was real projects with that build and test phase. That's when all the fun happens, when you're actually testing out your product, you're testing out your little project and seeing it work. So bottle rockets, we had a custom bottle rocket design challenge in physics class in high school, and that was really fun. There's a goal in mind. We're actually, putting a lot of effort into it, and everybody was exceptionally engaged. So that was really fun. In high school, on the bottom right here is a first robotics. So, I don't know if you have first robotics available at your schools, but if you do, I highly encourage you to get involved. It's really fun, getting to know your students as well, and seeing them extremely motivated to have their little robot work and do all these cool things. So upper right is or not the upper right, but the middle right is I think that's SE Formula Racing, which is a college competition. Very involved, but again, more valuable probably than any of the studies that you do in college for getting prepared for the real world and having those skills you need to be a real engineer. So, and yeah, upper right is just finally a product that you might make one day, real airplane. That's just a slightly bigger version of all of these things that you make down on the right. So, so yeah, you can kind of see the progression. And you probably already know this, but in terms of introducing science and engineering skills, so below high school, you could kind of do these same projects if it was below high school or at high school level. Some of them, but the concepts that are taught are probably just a little bit more in depth in high school. Well, a lot more in depth. So basic concepts like friction, energy, forces, or how different materials behave is like some good basic concepts below high school that can come out of these projects. And in high school, I know I took physics, and then I did AP physics. So we learned about kinematics and energy, and we did calculations to estimate how high a rocket could go, how far a marble could go on a roller based on its initial height, stuff like that, or even maybe how far a mousetrap car could go based on its potential energy in the spring. So, so when those engineering skills are connected to the actual project, then that's where I think the real engineering happens, and the learning happens. So, but I also liked growing up field trips, actually seeing things, demonstrations, science museums, rocket launches if you live near a launch pad, airports, just checking out planes and kind of learning about it and studying them, and or even factories, if you could go to like the Boeing factory or something, and just learn from folks there. It's very valuable. So that's all I have for my bulk of my slides. This is really just a demonstration for what we do at the STEM Council in Lockheed Martin Aculite at our site. So we do outreach based around optical engineering. So this is usually trying to teach students about basic optical physics, right? So how do light rays react? They can reflect or go through materials. How do they change their direction? All of that really matters for lasers because it determines where the laser goes. So we have to have a very good understanding of that. So we try to communicate this. Some things we do are lenses, mirrors, lenses, and teaching about the basic concepts like Snell's law of refraction here. So, and then once we teach them a little bit about the basic concepts, we have a hands-on activity. What we were able to do over the last year is virtually, we're able to use this optics simulator online. It's a free online tool where you can place light sources and then have optics redirect that light and create a pattern or move that beam where you want it to go, which is very similar to what we do here when it comes to laying out, layouts for layers, for lasers. So here's some example activities from that, replicating a eyeball. And this is, I think, collimating a lens, collimating the light source here, and a telescope. And on the upper left, a solar collector. So that's pretty cool. So just a short example of how the solar energy trough works here. The sun is a point source, and then this big concave mirror concentrates it down, and that in real life makes it focus onto this little tube here, which has the working fluid in it. So it's nice to be able to show how this little simulator is, it's nice to be able to replicate the real world application so simply and easily, and get that understanding that the physics of it aren't really that hard. The implementation might be harder. So, and then just a little bit more detail about how these different applications work. So not totally relevant to our discussion, but good examples for the activity to sort of just challenge the students a little bit about this concept and hopefully have them learn a little bit more. So yeah, that's it. Is there any questions?
There are questions.
Mm-hmm.
So also, thank you so much for sharing about the virtual activities. I think that's super cool. I remember in my physics classes, things around optics and like waves were really hard to study and to like learn about, because in some ways it's much easier if you can see them actually happening in front of you. So that's super, super exciting. And yeah, and I from my end, sending it out to all sorts of people to try to see if we can get some people engaged and interested in this, because I think it's awesome. Okay, so for some questions, and this is, I mean, I can vouch for also hearing this in terms of mechanical engineering. For students who kind of, I guess, would assume that like mechanical engineering is, just computer stuff. I guess, like, is there anything, that we can share with them that's encouraging in terms of, there is some, obviously a fair amount of computer work, but there are, some other, I guess, if you're just going to be interested in to know if there's what are other cool stuff that you do that's, even if it's on the computer, but just it's not just CAD all day.
Well, I guess I touched a little bit on actually assembling parts. So the most satisfying part of the job is after you design the thing and then you had the thing built and then it's in your hands in the lab. So not everybody gets to see everything, but everybody, I think, has the opportunity to go see the thing that they designed eventually. Depending on the company or the program that you work for, it could be a lot longer until you see that thing that you designed. So if you really want instant gratification, you could work on a program where you're doing a lot of little prototype work, or you need to make little things all the time. So, but it's also extremely encouraging when you have like a giant rib of an airplane wing that you designed and it's so beautiful, you spent so much time on. That's also really satisfying. So, so yeah, I mean, in terms of computer work, yeah, there's a lot of the CAD. It's way better to do it on the computer than drawing. I mean, you're not breaking your back, so you just can be happy about that. When you're if you're ever feeling bored that you're sitting computer too much doing CAD, but I mean, it's almost like a video game, so it's not bad. You're kind of spinning the thing around on your screen, and that's satisfying. You can make it pretty colors. So and then if you're it's a little bit of everything, and it's an extremely broad field, and that's why I wanted to go into it, because you have a lot of opportunity as a mechanical. You can do more just coding and really like physics oriented mechanical engineering, because you're different than a physicist in that you're really focused on the application. So so it's I guess that's a type of job that you are still very valuable in, doing analysis work of heat transfer and all that stuff, and all that you'll learn in college as well. Being able to do analysis of structures and heat flow. So, and that can be an interesting academic exercise where you sit down and you're actually just like writing out and trying to figure out the problem on paper. How exactly does this physics work? So that's different than the computer work. And then obviously being hands-on is the most fun, but or seeing the actual thing operate and work well, that's obviously the most satisfying. Yeah.
No, thank you, because I do think certainly the idea that you can see it at some point, and that it's a thing that you actually designed, I would imagine would be encouraging to students who are it's like, oh, sounds like a lot of computer stuff and really boring.
Yeah, I mean, I have a short attention span also sometimes, so that's also why mechanical engineering, I'm like, oh, things that move, it's fun. So yeah, so I like to be able to get up occasionally and just play with hardware, because
yeah. So that sounds pretty. I mean, I guess we want to work on some stereotypes. Just being able to manipulate things with engineers.
Mm-hmm.
And I guess, okay, so another question we have is, what would you say is your favorite part of your job?
That's tough. There are a couple favorites. My first favorite is when I get on a groove in design, and I start designing one thing and then the next thing, and then I just everything starts fitting together, and you're forming a sort of masterpiece in your own way. I guess in any job, you can, if you like it enough, you might consider it like an art. If you're really good at coding, you might create really beautiful code that's elegant, and you might just become sort of attached to it. So in terms of coding or designing mechanical parts, when things are working really elegantly together as you wanted, that's extremely satisfying, and you feel like, wow, I accomplished so much today. So that's probably most satisfying, I guess. All right, I would say that's second most satisfying. Most satisfying is definitely when your customer tells you this looks great or this works great, and And I get that occasionally because, you know, my customer sort of is often my lead who is internal to, you know, my company. So I give him something like a tool, and we use it and it works great. And that's the most satisfying. We're like, oh, we need this guy to make more stuff for us. And that's definitely the most satisfying recognition, right? So, but yeah, that and having the time to sort of create everything perfectly as you want and have ownership over your work.
Awesome. Actually, so it's on the same vein. What's your least favorite part of your job?
Probably making people do things who don't want to do things. Delegating work, that's not easy. Obviously, it's always easiest to do your own work, but sometimes you can't do everything, and that's a really hard thing to get over. There's a lot of people who just try to do everything themselves and are very stressed out, and it's not good. But you have to be part of a team, and if you invest enough time in your team, then generally you can have a good enough team that you can work like a well-oiled watch. So.
Well, and then how many people are on your team? How many people do you work with on your team?
I probably work with about 5 people regularly. My whole site here has like 190 people or so. But actually in the office these days, there's a lot less people. So it's like maybe 5 to 10 people that I work with regularly. Can stop by their desks, look at some designs together, brainstorm how to solve a problem, and somewhat normal still. So
yeah, I've been back at the office, and people are slowly trickling back in, and I gotta say it's really weird to see other people in this building.
Yeah, it's like, who are you? I don't. It's funny, but I've been here for the last year, so in the office.
Yeah, no, or you know, people I've accidentally surprised people a little bit, and they jump because they're like, oh, I was not expecting another human being literally in this building today, and I was like, oh, I wasn't either, so I kind of jumped too.
Right.
And let me see if you have any more questions. And actually one more question, and then we can wrap up. So I know with mechanical engineering, there's as far as, you know, I understand it, there's a couple different sort of, you know, and you alluded to this as like, you know, different directions you can go in with like mechanical engineering. If you like thinking back on sort of your own career, are there any other like sort of like niches or like, you know, kind of more specific areas of mechanical engineering that you think are super cool or wish you had gone into?
Yeah, so that's a good point. I'll expand a little bit on that too. So I think it's somewhat important to get very familiar with a certain type of technology that makes you very strong in that field. So you could become very good at energy systems. You could become very good at space. Then you'll be very employable at different space companies. There's a lot of that. I'm always surprised by how enthusiastic space people are.
Oh, they are so enthusiastic. Okay, I'm glad I'm not the only person who's ever noticed that.
Yeah, so space people are always really excited. And you know, it's very cool. So you can, once you develop a good baseline knowledge of that, it really helps you to connect with other space people and getting a job or even moving within a company is easier because you know about the technology and you can transition more easily. You have a better jumping off point. People think that you have a better idea of what you're doing, and you probably do. Yeah, so there's a lot of emergent technologies, and I think it's reasonably smart to sort of grab onto one. You have a good baseline knowledge and experience of a lot of different things, and then grab onto one and sort of specialize, know a lot about like a certain technology that I guess works with your lifestyle. Like, I want to work in space. I want to live in these different places where there's a lot of jobs for space people, and so in the end, that'll work for my lifestyle. So, so yeah. Let's see, energy, space, yeah, automotive. Those are just some examples. Yeah.
Awesome, thank you. Trying to think if I have any more questions, because I usually have 1,000 questions. I don't think I do, actually. So yeah, I think, yeah, I guess I'll see if anyone else has any questions they want to chat to me. I'm not seeing anyone. But anyway, yeah, but thank you so much for presenting, Andrew. Evan, thank you so much for joining us and, you know, popping in and helping me out with getting a presentation. And trying to think what, so yeah, so thank you both. If Audie were here, I'd also thank him. Thank you, teachers. Thank you so much for joining us today as well. Videos are taking about 2 weeks right now to get processed, but as soon as I get these videos together and some resources, I will send out an email with all of those updates, and I will also make sure to send speaker contact information. So if you're ever interested in getting in touch with any of the speakers yourself, and I'll be honest, everyone I've ever talked to at Lockheed has been absolutely wonderful. So, you know, especially with Lockheed, they're fabulous. So yeah, thank you all so very much for joining us. Thank you so much for presenting, Andrew. And I hope you all have a wonderful, wonderful evening.
Awesome. Thanks so much. Take care.
Thanks, you too.